You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome, everyone. Today we're exploring the really dynamic world where data engineering, AI, and infrastructure all meet. Our sources cover a lot of ground, from some serious cost-cutting wins to, well, major data scares and even some, frankly, wild ideas about storing information.
Yeah, quite the mix.
Yes.
Our goal today is really to give you the essential takeaways.
Exactly. The key trends, some surprising bits, and hopefully some practical stuff you can, think about or even use.
Think of it as a quick way to get up to speed.
All right, let's start with a big win then. Wix. They apparently managed to cut their data platform costs by a huge 50%. 50?
Yeah, and crucially, without hurting performance. That's a bit that often trips people up.
Right. So it wasn't just turning things off. How did they pull that off? What was the secret?
Well, it seems like a really methodical approach. One key thing was consolidating cost data.
Right.
Getting everything from different cloud providers into one place, like a central data lake.
So visibility first. Makes sense.
Exactly. Then they implemented standardized tagging everywhere. Super important for tracking. And they figured out how to attribute cost right down to the data level usage.
Okay, so that attribution piece sounds critical, knowing exactly what's costing what.
Precisely. It's a solid blueprint, really, for anyone looking to get costs under control without compromising the actual service. You don't have to pick one or the other.
Okay, so from cost efficiency to, well, data inefficiency. Or worse, let's talk robustness. There's this story about matrix.org.
Oh, yeah, that was a rough one.
A 3-day outage because of what? Silent Postgres index corruption?
Silent corruption. And the really scary part, standard tools like pgamecheck, which you'd normally rely on for this sort of thing.
They missed it.
Completely missed it, yeah, which really highlights a critical challenge.
So how do you even recover when your safety checks fail you like that?
It was tough. They had to bring out the, let's say, specialized tools, things like Page Inspect, to look directly at the raw database pages.
Wow, okay. Deep dive.
Yeah, literally.
Yeah.
And they used custom sampling to figure out where the corruption was. Then the fix involved a full reindex, basically rebuilding their massive 4-terabyte index.
4 terabytes.
Ouch. And restoring from backups, of course. It's a huge reminder that you need more than just the standard checks. Proactive, multi-layered integrity verification is, well, it's vital.
Definitely sounds like it. Okay, let's shift gears a bit towards machine learning. Our sources mentioned Apache Iceberg and SparkSQL.
Ah, yes. Game changers for reproducible ML systems.
Reproducibility. That's often the dream, right? Especially dealing with things like data drift and consistency issues. What makes these tools so helpful there?
They offer some really powerful features. Time travel is a big one.
Time travel, like going back to see previous data states.
Exactly. You can literally rewind your data. Plus, they handle schema evolution really well, so changing your data structure doesn't break everything downstream. And critically important, they bring ACID transactions.
Right. The database guarantees atomic, consistent, isolated, durable.
Yep. All essential for fighting data drift and ensuring your ML experiments are actually consistent and reliable.
And I guess that ties into the whole AI picture too, right?
Yeah.
Preventing AI hallucinations.
Absolutely. High-quality, validated data is fundamental. You need automated profiling, cleaning, checking against trusted sources, sometimes even using things like ontologies, sort of expert knowledge graphs to semantically validate the data. Garbage in, garbage out still holds very true.
It always does. Okay, so speaking of tools, the landscape is just exploding, isn't it? It feels impossible to keep up sometimes. Any advice from the sources for folks trying to navigate this?
Yeah, it's a common feeling. The core advice seems to be nail the fundamentals first. SQL, systems thinking those aren't going away.
Solid foundations.
Right. Then be intentional. Focus on maybe mastering just 1 or 2 new technologies a year. But do it properly, Build something real with them. Deep work, not just surface level dabbling.
That makes sense. Quality over quantity. But it does raise that question, doesn't it? How do you balance sticking with foundations versus jumping on the truly radical innovations?
It's a constant tension.
And speaking of radical, saving data to birds. Did I read that right? Starlings.
Haha, yeah. It sounds wild, doesn't it? But apparently, researchers are looking into how starlings with their mimicry skills could potentially encode complex data in their calls.
Okay, my mind is slightly blown. Bioacoustic data storage.
It's very early days, obviously, but it hints at these, incredibly low-cost research possibilities.
Yeah.
Moving beyond silicon, it certainly challenges how we think about information systems.
No kidding. and maybe a bit more down to earth, but still pushing boundaries. Apache Flink 2.1.0, unifying AI and data.
Yeah, that's more enterprise-focused but significant. They're adding things like AI model DDLs, so you can basically define and manage AI models like you would database tables.
Interesting, streamlining things.
And enabling real-time ML inference directly within your data streams, making AI much more integrated into operations.
Okay, wow. So we've gone from practical cost savings at Wix all the way to potentially storing data in bird songs. Quite the range today.
Definitely covered a lot.
Hopefully you listening feel a bit more informed, maybe a little more equipped to navigate this constantly changing data world.
Indeed. And, thinking about things like Flink's integrated AI or even the bird idea, it does make you wonder, as these systems get smarter, more automated, potentially more black box, does our reliance shift? From being able to verify the correctness ourselves to just having to trust the credibility of the system or its creators. How much scrutiny can we or should we apply when we can't easily look under the hood?
That's a deep thought. Relying on credibility versus verifiable correctness in automated systems. Something to definitely mull over.
For sure.
All right, lots to think about. Until next time.
Spoken Tech for your ears.